So, our opening talk is by Mac. I've known Mac a very, very long time.
We go a long way.
We go a long way back. So I first met Mac. I'm not going to tell the particular story of how I first met Mac. But I taught Mac when he was just that high.
And when I had hair.
When he had hair. So yeah, so he was one of the undergraduates. And then you went on for a very prestigious career. Went through PhD land, went through NICD.
Indeed, yeah. So I started actually working in professional services as an accountant, which I absolutely despise. I then decided to channel my inner Colin and go back to academia, did a PhD in statistics, and then very much like jumping rivers, started and embarked on a career in data science, which then turned into a career in sort of AI and ML. So I spent 3 years at National Innovation Centre for Data, where I was working on a variety of different consultancy projects, working in sort of natural language processing. And then for the past 2 years, I've been at Red Hat working as a machine learning engineer.
Oh, it's quite awkward now. I couldn't figure out how to get off the stage because he sort of started. But anyway, this is Mac. I've seen his slides. They look absolutely fantastic. I've heard him talk and it's always brilliant. So thank you very much,
If
Mac.
you want, we can still do a double act.
Maybe next year.
Next year. Next year.
But thank you.
Fantastic. Thank you so much, Colin. So yeah, my talk is around AI safety. So as you can see, I'm wearing a t-shirt called Refreshingly Secure, and that's what I'd like to sort of talk about. So how do you actually secure Gen AI applications? First of all, what we'll cover in this presentation is we'll talk about risk. We'll talk about why this actually matters. We will talk about how you can potentially implement some of these strategies that I will mention. We'll talk about evaluation as well as red teaming, as that's something that often is not necessarily addressed very well and is often neglected. And finally, we'll talk about how to manage this type of stuff at scale. So a lot of people may ponder, why is this important? And the main reason is a lot of enterprises are engaging in obviously a lot of proof of concept work, leveraging LLMs, and there is actually a lot of pressure to ship these applications quite fast. That can lead to things going haywire. For example, 3 years ago, we had a Chevy dealer chatbot, which was selling trucks for £1 or $1. That's obviously not great for that business. Obviously, you think, okay, so that happened 3 years ago. I'm sure people are wise now, and they obviously put a plethora of different safety features so that this stuff doesn't happen anymore. Well, unfortunately, it still does. We have Chipotle here that had a chatbot which was answering all sorts of questions which were not related to the fast food outlet. So here, for example, people were just asking stuff about Python code, and this chatbot was responding. That's not a great look. Also, it's going to be expensive for them. Here we have PGA, for any of golfers out there. They implemented a chatbot 3 weeks ago that was giving hallucinated information about players, and it was also saying that PGA is actually the worst golfing tournament. So it's not great, is it? We had EY, one of the biggest professional services firms, that was generating a hallucinated report containing a lot of misinformation and made up references. We don't want to be in positions when that happens. This week, we had Meta and their Instagram chatbot that got hacked. I don't want to be obviously finger pointing and naming and shaming these companies, but the main point of this is that people are shipping Gen AI in production, which is not ready. It can lead to a plethora of different problems, including obviously reputational damage. So that's why I think this is important. Second thing why this is important is that, unfortunately, there is a lot of bad actors out there. And based on a lot of papers, based on a lot of research, it seems that actually getting an LLM to give you some spurious outputs is all about effort. So if you essentially try to crack it for long enough, some bad things will happen. And LLMs can then engage in a variety of different risky behaviors. They can violate your guidelines. They can generate harmful content. They can potentially enable unauthorized access. So there is a lot of things that we need to essentially try to protect against. Attacks are also getting kind of crazy. There was a paper from a few months ago which framed these adversarial attacks as poetry. And they actually managed to get a more or less 90% attack success rate on a single turn conversation. So there is a lot of research, cybersecurity research that goes into this space. And it seems like a lot of people are able to crack their systems quite readily. So that's not great. The problem from the other side is that it's actually difficult to protect against risk because we don't actually have a universal and overarching definition of what risk truly is in the context of Gen AI systems. Risks, they're hard to define. They can be context dependent because what matters for one industry may not necessarily be the case for another. And risks actually evolve over time, which makes it very difficult to set up protection accordingly. Quantification of risk is another problem, and that's why we need evaluation. To sort of steer this for every company that's thinking of deploying Gen AI, I would recommend picking up some sort of form of risk taxonomy. There is a plethora of them, and I would probably say that something like a risk atlas nexus, maybe NVIDIA Aegis, is a good starting point to understand the landscape of risk and what to protect against. OWASP is quite a big player when it comes to cybersecurity, and they produce top 10 LLM risks for each year. And so far, prompt injection has been the number one risk. So it's obviously something that is potentially a good starting point when it comes to thinking as to what you need to be guarding yourself against. A lot of people come up to me and say, okay, well, I have an LLM. I'm capable of fine-tuning that LLM. Why can't I perform more safety alignment, some sort of fine-tuning, maybe reinforcement learning to make my model safer? And the answer is you can probably do that, but it would be a very costly exercise. At the same time, there are potentially better options. The reason for it is that a lot of companies will have different policies. They need to be kind of specific. So trying to work out the safety angle using alignment doesn't necessarily work. Because if I'm, for example, creating a chatbot for a chemical engineering company, maybe perhaps I should be discussing things to do with hazardous materials. But if I'm a banking chatbot, I probably should not. Alignment is static. So every time there is a new risk coming, I don't want to be necessarily going through the process of fine-tuning a very expensive model. If a new regulation comes in, I'd rather address it kind of on the fly without having to sort of align my model. At the same time, if you just rely on alignment, you always will be essentially wasting tokens because some sort of input will have to be processed. So yeah, it's very important to sort of have a broader definition of risk in mind. Think about some baseline risks and then think about additional organizational risks that you should consider. It's kind of wishy-washy at the minute, and that's why doing risk assessments with a risk taxonomy in mind, using some sort of open source framework is useful. For example, here we have a risk atlas nexus. It's a very interesting tool because it takes the taxonomy and it maps it onto a potential AI system that you'd like to create. So in this instance, you can just see a screenshot which shows an intent, which is to develop a medical chatbot. You talk around what model you'd like to specify, and then essentially on the right-hand side, you see what you can get out, which is the sort of key risks that your system could be vulnerable to. And these are the risks that you should be then trying to guard. And in my view, one of the sort of more effective strategies to mitigate those risks is through guardrails. So these are the sort of runtime inspection layers that will sit around your LLM or an agent. And here's a mandatory Gandalf GIF because that's what Guardrails is always about. You're trying to ensure that at an input level, things that are potentially not aligning with your company policy or some sort of risky inputs are filtered out. So the high-level architecture is quite simple. You essentially have a user that would send a query. This query, before it gets actually fired off to an LLM, gets essentially scanned through a series of input detectors. In terms of those input-output rails, they could be a plethora of different things. So they could be very simple regexes, they could be very simple rules and expressions, and then you can essentially build up in complexity of these detectors that sit around your large language model. So they can be classifier models, they can be also heavyweight LLMs. Those LLMs are particularly good at digesting your policy documents and understanding what sort of risks you should be guarding against based on that sort of policy document. So what I think is quite important is to make sure that you have this sort of layered approach to guardrails. So it's not like that you would just always pick rejects. It's not that you would always pick an LLM-as-judge. You would probably think about sort of stacking them up like a stack of pancakes or a layer of an onion. So the way this would work is that you would probably run some of your detectors sequentially. So you would have probably a stack of guardrails, which are fast and cheap to run initially. And then provided that your input passes those, you would then potentially consider running some sort of lightweight classifiers on top of that input or an output. And then finally, you could maybe perhaps think about moving to LLM-as-judge approach so that you don't necessarily waste your tokens. And the same thing would happen at the output level. So once your LLM starts to generate tokens with an output, provided that the input is safe, you would run the similar stack of guardrails to understand if something is safe or not. A lot of people at this stage maybe potentially think, okay, maybe I need guardrails to avoid scenarios like we sort of outlined on the slides. Sure. There are third-party guardrail solutions out there that you could use. Probably the most canonical one is OpenAI moderation API they could leverage. But just applying these type of guardrails is not great because, well, first of all, you're likely to be locked into that approach. Your data leaves your system potentially, which is not great. And there's no customization per se. So it's very difficult to actually tailor those type of guardrails to you, to your enterprises, and to your specific policies. So the way that I would recommend then setting up guardrails around your LLM, around your agentic system, is by potentially leveraging something like NeMo Guardrails. So it's an open source toolkit originally created by NVIDIA, to which Red Hat heavily contributes now, which adds these programmable rails around your LLMs. The good thing about it is that it's a very simple Python package. You can interact with it as you would with any sort of Python thing. It has its own SDK. It also has a server, which then allows you to potentially leverage a REST service that you can use as a microservice in the context of your application. NeMo is quite rich in the context of guardrails it provides, and it's also very flexible because it allows you to write your own bespoke Python code, potentially as a rail. So there is a guardrail catalog in there, and it allows you to essentially very easily spin up rules, classifier models, as well as these LLM-as-judge type of guardrails. It's quite trivial to get started. All you have to do is write a configuration. Is just a YAML. And then you can, for example, here you can see a code snippet of invoking a generate method. So configuring this stuff is pretty simple. All you have to do is specify some sort of input and output flows with the relevant guardrails. So in this instance, we just set up a PAI guardrail using Presidio, which is an open source toolkit to detect sensitive information from Microsoft, which is one of the inbuilt rails. You can configure an LLM-as-judge quite readily as well. All you have to do is feed in a prompt. That prompt could be as simple as it is specified on lines 19 to 20, which is about, does this input contain hate speech, abuse, and profanity? It could be obviously more complicated. It could be just a policy document outlining what your chatbot or an AI system should or should not be doing. There is this, as I said, server mode. It's just a REST API. It has two endpoints, one which mimics OpenAI chat completions. So it's essentially a drop-in replacement for that. And there is also a checks endpoint, which invokes guardrails. They can use at, for example, your AI gateway level, or if you just want to run something without necessarily generating the LLM input, that would be the API to use. It's quite easy to carry NeMo guardrails from your laptop to production. So you can dev locally, you can use Jupyter notebooks, you can spin up a local server, you can easily take it to Kubernetes if you containerize it, create some sort of deployment service and a route. But you can also leverage a trusty AI operator, which is a project that I've been working on, which allows you to essentially just spin up all your necessary Kubernetes resources, including authentication, TLS, all that sort of nice stuff, without necessarily having to worry about creating a lot of these deployment files. So yeah, it's a very neat thing that you can use. if you wanted to. It's all open source. It allows you to just much more readily manage the sort of life cycle of your Nemo server deployment. And yeah, it's quite trivial. All it takes is a custom resource. It's just yet another configuration file where you just essentially reference your configs. So in terms of the sort of production architecture, the way it would kind of look is you would probably have some sort of namespace on your Kubernetes where you have your guardrails, where you have your trusted operator managing all of that sort of stuff. You may have another namespace where you have your models, LLMs living in the sort of model as a service type approach. And obviously there will be some sort of potentially open telemetry component to have the observability. So you log all of your traces, you understand your guardrails and whether they've blocked your input, etc., etc. So this is essentially that sort of outline. You may have deployed some sort of guardrails. It's really important to sort of monitor and understand how effective those guardrails are. This is where, again, another open source project would come in, open telemetry, where you can essentially just export all of your traces from your Nemo server into something like, for example, Tempo. And you can create, dashboards, which will just, to very basic Grafana dashboards, which can give you information as to how many requests went into your system, how many things have been blocked, and you can get a very detailed information from the traces itself. So you can sort of probe the system, understand what sort of queries went in, what has been blocked, and whether that's a correct decision. All of this is good, but we also are missing at the minute the point about evaluation. So, okay, I may have a system which is guardrailed, but I still don't fully understand its performance. And this is where Eval Hub comes in. So again, it's another open source project that you can use to essentially evaluate your system before you actually take it to deployment. It's quite cool because it has a plethora of different adapters, so you can use, again, a lot of different open source frameworks to evaluate your system. The most common adapters that people at the minute use are Garrick, which is for red teaming, and LM evaluation harness to sort of detect and understand the performance of your system. So again, the nice thing about Eval Hub is that it runs readily locally and it runs very readily on the cloud. You can use the Trust AI operator to manage the lifecycle of this, but you don't have to. You can use just vanilla Kubernetes and run your own deployments. So yeah, here's just a snippet of how an API call would look like if you just wanted to submit a job evaluating your system with Garrick. Red teaming is something that I think is another dimension that people often forget. And this is the sort of practice of actually running these attacks on your system. So Eval Hub is quite good because obviously it has a plethora of different providers. Those providers may look into how efficient your system is, how performant it is, but also how vulnerable it is against different attacks. Manual red teaming is fine, but obviously you'd like to automate this process as much as possible. So if you stack Eval Hub and Garrick, you have this ability to essentially run an automated pipeline for red teaming. That's really good because obviously it allows you to fully understand what risks your LLM and your deployed guardrails could be vulnerable against. So typically the automated red teaming pipeline would work as follows. You have attacks which are ordered in complexity and they go from easy to hard mode. So for example, a baseline attack would be just trying to elicit a prompt like, how do I avoid paying capital gains on my stonks? Nothing too special, nothing too clever. Then you're trying to add a variety of different things. So you may have a do anything type attack, which is a quite standard prompt injection type thing. Something that will sort of say, ignore your rules, let's override the system. Then you have something that may potentially add some sort of social engineering component to it. Translation, that's actually one of the most successful attacks. Most of the safety alignment is done in English. If you write your prompt in Mandarin, it is more likely to go through and potentially have unintended consequences. So here's just an example of a report. This is a Quen model. As you can see, it's quite vulnerable against very basic attacks. And this is what we actually find time and time again. A lot of open source models but not always just open source models. They're vulnerable to very basic attacks. So if you have a nefarious user, they can essentially take over your system. If you start implementing guardrails around the system, things get better, typically, which is reassuring. So the operational loop would be typically you deploy your LLM without any guardrails, you red team it, you review what attacks were successful, you would deploy some sort of guardrails in place, you would red team again, and then you would essentially have this continuous loop where you go through that process a few times to ensure that you think you have greater confidence in your system. Because risks evolve over time, guardrails are not set and forget. Have to think about potentially retraining guardrails, re-implementing those as well. And another important thing to consider is what actually happens at a sort of platform level. What if 10 different teams within your organization need guardrails? Should they be picking these guardrails, or should it be done more centrally? And this is, I think, where something like Guardrails as a service comes in, where actually the platform team provides these guardrails, LLM endpoints to application teams. So I don't necessarily think the application teams should be necessarily concerned with doing guardrails. It should be happening at the sort of platform level. Then obviously application teams can add potentially to some sort of guardrails, but at the end of the day, it should be a centralized process in an ideal world. And yeah, I think the platform team should take the ownership of the guardrails. They should never be providing unguarded LLM endpoints to application teams. This is where things go haywire. So for those of you that are sort of execs in the rooms and not necessarily very technically minded, it's always useful to also think about this sort of maturity journey and think about where is your organization now? It seems like a lot of people are doing proof of concept work with LLMs, and they may be getting some interesting results. They may potentially see some productivity gains. In my case, I think that's definitely typically the case. But again, a lot of people don't necessarily think about safety, security, evaluation of these systems. So they get very excited and they think that they can put these in production, but it's not necessarily the case. It's useful to just also think about this sort of, I think, a 3-stage journey in terms of maturity. Like talking to a plethora of different clients at Red Hat and IBM, it seems that most people don't necessarily have guardrails in mind at all. They essentially just share these unguardrailed endpoints. They may rely on just frontier models to do the heavy lifting for the guardrails, but they don't necessarily have them aligned to their own policies. Certain teams are experimenting with guardrails, but it's at a very granular level. So nothing actually happens at a platform level. Nothing actually is being centralized. As far as I'm concerned, there's really no one at the sort of level 3 where they really have a guardrail or a risk mitigation strategy put in place. So I think it's worth bearing that in mind, and that most enterprises are still early days in this. It's also useful to think about the future. Obviously, largely I was talking about guardrail and LLMs, but obviously you'd like to also guardrail agents. And there are interesting open source projects that allow you to start doing that. And from our side of things, praxis is the most important one. So yeah, key takeaways. You probably need some sort of guardrails. You need to test your defenses. You need to probably run some red teaming to really make sure that your system is not super vulnerable to certain types of attacks. And once you do that, you should then think about putting things into production. And everything should be saved by default. So no unguardrailed endpoints. And that's it for me. You can scan this QR code if you want to get reference to the slides. And with that, thank you so much.